So, good day everyone. Today I will discuss a data structure which is about heaps as a final project for this semester. So, let's proceed. So, first, to understand its structure, we need to understand what is heap. So, heap is a socialized tree-based data structures which is essentially an almost complete tree that satisfies the heap property. It maximally efficient implementation of an abstract data type called priority queue. A useful data structure when it's necessary to repeatedly remove the object with the highest or lowest priority. Now, generally heaps can be two types, a max heap and a min heap. So first, what is max heap? In a max heap, the k represented at the root node must be the greatest among the k's represented at all of its children. The same property must be recursively true for all subtrees in that binary tree. Min heap also has the k2 present at the root node must be in minimum among the k present at all of its children. The same property must be recursively true for all subtrees in that binary tree. Now I got an example about the heap data structure. This is a min heap and a max heap. In min heap, the parent nodes must always be lesser than its children, children nodes. While in max heap, the parent's node must be always greater than its children nodes. Now, to understand, when are heaps useful? Heaps are used when the highest or lowest order priority elements need to be removed. They allow quick access to an item in a very short amount of time. One use of a heap is to implement a priority quick, while in binary heaps are implemented using array, which save overhead cost of storing pointers to child nodes. Now, sample of heaps in its application. Consider a supermarket line. How can you model a line of customers waiting to pay for their items as a max heap? Now, one way to model this problem is to build a heap where each person in the line is represented by a node. The node's value will be correspond to the amount of time that the person has stood in the line. People who have been in the line longer and are therefore towards the head of the line will always have a larger k value. Keep in mind that this is a max heap. So, the people who have been in the line longer should be the parent node. And the root node of the heap will be the person who has been in the line longest. So, sample codes in heaps in Java. So, I prepared a sample code for Java which is this. In order to make a heap, we need to make first, of course, a class. A class where it has, this is just a common example of an heap, and you can find various ways to make heaps in Java, even in other programming language. So this is the variable of my class, where L is equals to 2 multiply I plus 1 and R is equals to 2 multiplied by I, which is the size of the array plus 2. And this is the logic for the heap, that if L is less than size, and then it will get this variable. And if R is less than size, then it will get this variable. Now this is the method for inserting nodes, and this is the method for deleting nodes. And this is the example I created, that if you insert an array with a number of 3, 4, 9, 5, 2 and display it in a array and delete a one element, which is 4, and display the element after deleting a specific node, which is this element. So if we run this program, it will display the max heap with all the elements I inserted. Oops, where is it? So after I display this program, it will display all the elements I inserted. And when I deleted the array 4, which when it will display these elements, where the 2 rather replace the 4 elements because it was removed. Now that would be the example, and this is just a type of a max heap, one of the 2 types of heaps, and I choose this program since it is in the problem here that I use a max heap, where our larger value will be the parent node. So that's all.